Types of mesomerism. As we know that there are two types of mesomeric effect. One is called as plus M effect and the other is called as negative M effect. Now what is plus M effect? If electron donating group is attached with conjugated system, it will be called as plus M effect, and if electron withdrawing group is attached with conjugated system, it will be called as negative M effect. Now what are the electron donating groups? Basically they are chlorine or fluorine or hydroxyl group. And what are the examples of electron withdrawing groups? These can be carbonyl group or cyano group. Let's take an example of chlorobenzene. So here we have a conjugated system in the form of benzene ring with attached one chlorine group, and the chlorine has actually 3 lone pair of electrons. How can this chlorine atom transfer its plus M effect to this conjugated system? We will draw our double-headed arrow here like this, and now concentrate on this lone pair of electron that is actually facing this bond, that is quite nearer to this line. So what we're going to do is the bond that is next to the chlorine atom will actually acquire this lone pair of electron. So we will draw arrow that will be started from this lone pair of electron and will fall in between the bond. So we will get conjugated system with double bond chlorine plus chlorine will acquire a positive charge. Now what will happen to this bond, because it is next to the single bond, so we will draw it onto this corner so that it actually can represent the carbon bond with negative charge, and the whole system will remain the same. Now remember that these two structures are actually the resonating structures of benzene, and the effect produced is mesomeric effect. Remember that this is actually a pi electron that has now been converted into a lone pair of electron onto the carbon atom. So carbon atom with a negative charge will actually called as carbonium ion or carbocation. Anyways, we are heading forward and trying to draw further resonating structures of chlorobenzene. Again, this lone pair of electron will jump in between this single bond, and this pi bond will be shifted onto the corner of the carbon atom, onto the corner to represent carbon atom with negative charge. So negative charge here and double bond, and the whole system will remain the same. Let's discuss further delocalization of this lone pair of electrons that will fall in between these single bond, and the next pi bond will be shifted onto the corner, and we will get this corner negatively charged. Let's draw further. This lone pair of electron will be shifted in between the next single bond, and this pi bond will be shifted back to the chlorine atom so that it may get net charge as 0. Now, now concentrate on these lines that are actually representing the pi bonds. These lines are exactly replica of each other. So we will say that there are 3 resonating structures of chlorobenzene. And this effect that has been produced is a mesomeric effect.